So you are given 8 different elements indexed 0 to 7, and what we are going to do is we are going to pick up the second element, and we are going to say that the array to the left of it is already sorted. So I have to find the right index for element which is currently at index number 1. Now it makes sense because there is only one element to the left of it, and if an array has only one element, that array is already sorted. So next we pick an element at index number 1, and we compare it with every element that comes before it, and if the other numbers are greater than the number that we are currently looking at, then we are going to move all the other elements from the left subarray one step forward till we find an element which is less than 6, and once we find that element, then we are going to place 6 just right to that element. So you pull 7 to the right, you still have a 7 at index number 0, but we are going to override that with 6. So now we end up with a subarray of size 2 which is sorted 6 and 7. The next step is to pick the next element, index number 2, and then we are going to compare this with the elements that come before it. So the subarray comprised of index 0 and 1, we are going to compare every element in that subarray with this number, and we are going to place this number at its correct position. So next step, 6 and 7 were both greater than 4, so both of them had to be moved one step to the right, and we are going to place 4 there. The next part is to pick element at index number 3. We compare that element with every element that comes before it, index 0, 1 and 2. And since 2 is smaller than all the 3 elements before that, all the 3 elements have to be pulled to the right. And we place 2 at index number 0. Now the next step, pick up number 4. Now 9 is already greater than every element to the left of it, so we are just going to place it back. Element 8. Now 8 is smaller than 9, so 9 we have to pull 9 to the right, but 8 goes just before that, because 7 then you see is smaller than 8, so we don't have to take 8 leftwards. And that is how this entire algorithm progresses. And we can just go ahead and we can check every single element. Now 3 was greater than 2 but less than 4, so 3 goes to index number 1. And the next element is 5. Now 5 is greater than 4 and less than 6. So basically what we are going to do is we are going to keep comparing 5 with its previous elements till we find an element which is smaller than this. And once we find that element, we are just going to place 5 to index 2 plus 1 at the position 2 plus 1, because the index number 2 has an element less than 5. So we find the next index which is 2 plus 1 and we place 5 at its position. Now let's write some code and let's see how that works. So I've created a class called Insertion sort, and in this I'll be defining a method called Insertion sort, and that method will accept an array and it will sort this array based on the same algorithm that we discussed, and it will send back an output. So void insertion sort, that takes an array which is not sorted, and yeah, that is what it is going to do. Now the next thing is to iterate this array. So we'll take step, which is which index are we considering right now for creating the sorted left subhalf, and int step is less than, let's create an element called size, which will be just the length of the array. Now I have not written Java code for a long time, so this happens. Now the next thing that we have to do is we have to take a reference, not the reference but a copy of the rightmost element. So right edge, I'll just call it right edge, that would be array of step. So now we have a copy of the rightmost edge, and now we have to compare this rightmost edge with every element that comes left of it. So to do that, we are going to take a while loop, and this loop goes on for elements from 0 to right edge minus 1 index, step minus 1. So while j, or the element at rightmost part, while that is less than array of j. Now j, we haven't defined j. J is just one element left. So j, if you're looking at index number 7, j has to be from 6 all the way back to 0. So j will be 7 minus 1. So 7 is our step, so j is going to be step minus 1 all the way to 0. So that is j. J will go all the way to 0. So the next condition is, and before doing that, j has to be greater than 0, right? Or equal to 0. So while j is greater than or equal to 0 and the element at rightmost edge is greater than these elements, we are going to keep going backwards. And once one of these conditions is false, we are then going to break out of this loop. So, but before that, till this condition is not satisfied, we are just going to pull all these elements one step forward. So what we mean by that, programmatically, we'll write it as j plus 1 equal to array of j, and we are going to decrement j, and once either of these conditions is met, we are going to break out of this loop, and we are going to place this right edge, because this is a number for whom we were trying to find the location. So now we have found that, and j plus 1, because this 4 was actually less than 5, so we have to place 5 at index 2 plus 1, right? So that's the same thing we are doing. J plus 1 takes the right edge, and that's the algorithm. Now we just have to write a function that creates an array, sends it to the function, and prints out the output. So that will just be our main method. And I'm just going to put some random numbers, and then we are going to create an instance of this class. So that will look like insertion sort is equal to new, and then is dot insertion sort, and we are going to send this array, and then we are going to print it. And of course we need to import this, and to print it, so dot print line. So that should be it. We should be able to see the correct output, and yeah, that's the correct output.